Good morning, everyone. My name is Chelsea Duffy, and I am the Executive Director for Partners in Education. And I am so excited to see at least 12 classes joining us this morning from all across Santa Barbara County, Lompoc, Santa Maria, Santa Barbara. And a huge part of what Partners does is help students discover and prepare for their career dreams. And so that is what today is all about. I'm going to share my screen just to give a few images to set up today's panel. We are so thrilled to have an amazing panel for you this morning. Today, the panel is all about jobs in science, technology, engineering, and math. And a huge thanks to Raytheon Technologies for sponsoring today's panel. Raytheon is a Fortune 100 aerospace and defense company with over 250,000 employees worldwide, including in Santa Barbara County. Raytheon invests millions of dollars in STEM-related activities every year internationally, focusing on high school and junior high school students. And the number of available well-paying STEM jobs is growing every year. You will hear today from one of their associate directors, Neil Dayal, who is also a board member for Partners in Education. We are also thrilled to be joined today by two other STEM organizations, local organizations. Karl Storz Imaging is a global manufacturer and distributor of medical devices. And we are also joined today by the National Center for Ecological Analysis and Synthesis, which is a research center at UC Santa Barbara. Our moderator today is Gustavo Ramos, a student of the Career Technical Education Center and Agriculture Farm at Santa Maria Joint Union High School District. This 25-acre facility is taking hands-on education to the next level. It's a truly amazing space. Gustavo's favorite classes are currently machining and welding, and the career path that he is most interested in right now is automotive technology. So please join me in welcoming our moderator, Gustavo. Gustavo, thank you so much for being here today. How are you today?
Good.
All right, well, I hand it over to you. Have fun.
All right. So hello, everybody. My name is Gustavo. I'll be your moderator for today. And today I'll be asking questions on behalf of Santa Barbara County students. And for the first question is, can you guys please share your name, company, and what is the most fun thing about your job?
Good morning, everybody. My name is Neil Dayal. I'm with Raytheon, and thank you for that intro, Chelsea and Gustavo. I'm an associate director for our space programs here in Goleta, and we have about 2,000 employees across the Goleta-Santa Barbara corridor here. Some of the fun I like to have is solving problems with some of the best and brightest that are in the area and what they work on. If any of you have used a microwave before, guess what? That was Raytheon a long time ago. If any of you have used Google Maps, yep, that was part of Raytheon as well. We built the sensors that let you look down. And I got a phone call from people at some of the best and brightest, like Jet Propulsion Labs will call. They did a few years ago and said, hey, we'd like to set a mission up to do a flyby and see if there's water under the planet of Europa. Can you build sensors that would allow us to look under that 30-minute window? So yeah, I have a lot of fun doing that with people. Solving tough challenges with individuals is where a lot of what Raytheon operates under. And you know, we have a lot of engineers and a lot of people that are not within engineering as well. But that's what gets me excited about what I do every day.
Good morning, everyone. My name is Sara Colon, and I'm a design verification engineer at Karl Storz. Okay, so I have actually a lot of things to share in terms of what fun I have. So in my current role, I'm a little bit of both a design verification engineer and also a lead for some of our projects. But I must say that between the two roles that I often have on a given day, the most fun that I have deals with breaking things, because at design verification, my job consists of finding problems and informing those who I work with, which range in all the disciplines from electrical engineers, manufacturing engineers, system engineers, project managers as well, and informing them of what works, what doesn't, and then how to best fix the issues. And my work doesn't just involve in new products, but then also products that are outside in the field that come in with problems that we don't know exactly what's causing the problem. So in that kind of investigative work where you don't know exactly what you're working with, and you have to develop different tests, procedures or ways of figuring out, troubleshooting and figuring out what the root cause of the problem is, and informing, like I said, your team. That's honestly the most fun that I have. And let's see, as far as the on a personal level, the other thing that I do like about my job, even though we're more in a hybrid model right now due to COVID, I do enjoy my team members and socializing with them, even if it's through Teams or Zoom. I must say that I'm very fortunate to have a very good team in my own department. Thank you.
Good morning, everyone. My name is Sam Chick. Like Chelsea mentioned, I work for the National Center for Ecological Analysis and Synthesis, which is a total mouthful, so we go by the acronym NCES. We are a part of UC Santa Barbara, but our offices are located downtown near the courthouse, if you're familiar with that area. Our research center is a little bit different than some of the labs on campus. We don't run new experiments to collect data that way. We use existing data because there's a lot of it in this world already to answer exciting and important questions about environmental problems. And so we call that data science, environmental data science. And I think that's the most exciting part of my job. The tools that we use, the programming languages, the technologies we use to work with those data evolve really rapidly. Like if you think about your iPhone and how different it is from, the iPhone that we saw 5 years ago, even, like technology changes so quickly. And so it's the same thing for the tools that we use. And so I just am constantly encouraged to learn and to be able to share what I learn about how to use those tools with other people. So it keeps my job very, very exciting.
Hello, everyone. My name is Jorge Jimenez. I work for Karl Storz Imaging, and I actually work in the same department as Sara. So to start with, I actually do really enjoy working with my team members. Sara is a really good team member that has supported me and helped me during my transition into actually working at Karl Storz Imaging. I actually graduated from UCSB recently. But one of the things that, I guess, going into the question that I enjoy the most is actually working on medical devices that will eventually be at a surgery room or used by a doctor to help save maybe someone's life. Could be, the change in someone's life at a surgery room or just anywhere in a hospital. But going into the technical side, what I do enjoy is being able to use, a little bit of everything. I enjoy using a little bit of computer science, a little bit of electrical engineering, a little bit of mechanical engineering in order to actually be able to do my job. So just putting everything together into one single field is what I enjoy. And we can go back to you, Gustavo.
Okay, thank you for your responses. For our next question is, can you briefly describe what a normal day-to-day looks like at your job?
Sure, yeah. There are, I'll say, typical days and non-typical days. Right now we're working on a big program called Next Generation Interceptor. So many of you might know there's something going on across the world right now. There's a war with Russia and Ukraine, and something could fly over and that has nuclear tipped abilities and really hurt a lot of people. And so we build sensors that go on the front end that can hit those things out of the sky before anyone could get hurt, right? And so we use that to protect our friends and allies across the world, and that doesn't happen by itself. So there's a lot of meetings, as you can imagine. There's a lot of suppliers we have to talk to. There's a lot of design work. There's a lot of financial preparation, making sure all the dollars for those programs are met. We'll probably break out the day with a mentor meeting. We have a lot of new employees that come to Raytheon that might start day one, and we talk to them about what they can and should be doing next in their career. And we also look at future proposal strategies, right? So that we can look at what next thing is coming about. So that might be a typical day. A non-typical day, I'll share with you, my college roommate called. I hadn't talked to him in 10 years. And he says, I'm in Helmand province. I'm taking live fire. Do you know the Raytheon so-and-so number radio communicator? And I'm like, what are you doing calling me? You're taking live fire. So I called them back in 5 minutes and used our company intranet, because it's a big company, you don't know everything about everything. And we called back, and we had our technical person that knew the radio the best on the phone, facilitated them with this conversation around the world, and got their radio communications back online. And it was really rewarding. There were 40 people that sent a flag 2 weeks later, didn't expect anything, that said, you kept us alive that day, and appreciate what you did. So that might be a non-typical day at Raytheon, but does happen. Sarah?
Thank you, Neil. So I also have typical days and non-typical days. So as I mentioned to you earlier, Gustavo, I am a design verification engineer, but I'm also a lead for some of the projects that we have here at Karl Storz. Lately, I've been doing more of that non-traditional kind of days, non-typical days, not traditional, but non-typical days, where I'm currently working on a high priority project, because we have a product that we released last year, and it was sent out to the European market, where some of the doctors were, I guess you could say, test trying them. It's not fully out in production, or at the time it wasn't fully out in production, being sold to various other doctors and customers per se. And it came back with some issues related to the image. And in the field, I guess you could say that it was sent back to us to resolve the issues. So currently we've been working on that. And as a lead, I'm having to work with, as I mentioned to you earlier, Gustavo, various other engineers, and we've found the root cause. Now we're transitioning over more toward developing a test plan and figuring out how all of that's going to work. So in the last couple of days, I've been involved in a lot of meetings, ordering supplies and ensuring that we have everything to execute our plan, as far as verifying it and ensuring that the issues have been thus, resolved. And then that way we can now restart the production, because currently our production line downstairs is on hold until we guaranteed the company and our customers that the problems have been resolved. But on my more traditional days, I would say that I have a few meetings and then a lot of testing in the lab. Although, like as I mentioned, I'm transitioning more of on a kind of lead role, so there'll be a little bit less of testing for me, more, I guess you could say, managing the project in the near future. Thank you, and then I'm going to pass it to Sam.
Thanks, Sarah. My day-to-days change a lot. Seems like everyone else is in a similar boat, but that's what keeps it exciting. A large part of my job is, like I said, developing workshops and lectures, and helping to refine the curriculum for this new Master's in Environmental Data Science program that just launched this year. And what that means is spending a lot of time teaching myself first how to use different tools. One thing I'm learning right now is a bit about cloud computing, which is running really complex and computationally intensive processes on machines that aren't your own computer. It's somewhere in the cloud, is what the buzzword is, but a machine that's hosted elsewhere that has a lot more power than my laptop does. And so there's some complex processes that go into actually connecting to those computers that are farther away and using their resources. And so it's become a big tool in the data science realm. And so that's one thing I'm trying to teach myself so that I can teach others how to use that next week, actually. Aside from building these workshops, I'm also working with faculty at UCSB to refine the curriculum and decide what courses these students should be taking to really set them up for success as they move into the workforce. It's only an 11-month long program, master's program, so it's pretty short. It's a lot packed into those 11 months. And so we're excited to see where they all end up in June, which is just around the corner all of a sudden. We also have other groups within NCs who lead trainings on how to use different data science tools and coding skills for researchers all over the world who are looking to better their skills in that realm. to learn to work with the data that they've collected, running their own individual experiments. And so a small group of coworkers and I are working on setting up scholarship funds to help fund people to take those courses that might not be able to afford them otherwise. So that's another fun side project that I've been working on. And with that, I'll pass it over to Jorge.
So for me, it's actually pretty interesting. And so right now I was actually placed on a project, on a completely different project that I'm pretty much just learning about. So it's a lot of pretty much learning, just following, asking questions, reading and stuff like that. So I guess something more interesting, I could talk about what I was doing actually a few weeks ago. So just a few weeks ago, I was actually doing, like Sarah said, as we work in the same department, like 50% of my time, like half pretty much of my time I was doing on like actually testing, working in a lab, doing setups, collecting data and analyzing data. And that's pretty interesting just because, you're able to create a setup, work with your hands, make sure to tune everything the way it should be tuned, with the specific kind of setups that we have in our procedures. And then, once you collect data, then, I usually go back to my cubicle where, I use software, mostly MATLAB in order to analyze the data and, be able to get results. Then that goes into kind of like the test reports that we write. So usually day to day could be in any part of that pretty much that process where, I'm either one day pretty much just testing and collecting data like all day, or maybe another day I'm just pretty much analyzing data like all day and writing code, or maybe another day I'm pretty much just writing a report like all day. It could be a mix of things. Also could also include some meetings. But something that I really find really interesting every day, I was actually working on kind of some of our automation efforts, and pretty much what automation means is we're trying to make everything kind of, I guess the way to put it, it's so that it can do it by itself, right? You just come in, set it up, press a button on a computer, and then pretty much analyzes everything, collects all the data for you. So that's something that I really enjoyed, and that was usually part of my day to day. So that's something that I guess that's how my day to day usually goes. Just could be a mix of things, but those are some of the things that I work on. And we can go back to you, Gustavo.
All right, thank you. I think it's safe to say that in most STEM careers, it differs from day to day. As my classmates and I try to decide what we want for our future, I want to know, how did you guys decide the path you are on is the right one for you? And what are your strengths?
Yeah, great question, Gustavo. I started off thinking, I wanted to go into construction. I could work outside. I could, get my gym activity in while I was doing that. And then I was talking to my parents, this is back in high school. They're like, what about you? You like to play video games? And it led over to computer science. And so dabbled with computer science. That's why I got my my degree in my undergrad. And so I started writing code with Raytheon, and there's probably about 1 million lines of code on planes and aircrafts since then. And one of the things I realized is, I preferred working with teams, and more preferred in working a little bit with the individuals as well as the engineering, and realized that there are other areas, so many other sub divisions within engineering that you can work under. So systems engineering was where my next step was after that. And then eventually into program management, where you're working on programs, interacting with engineers and other functions as well. So really appreciated that. And the lifestyle changed a little bit, because I went from being an individual contributor to working with people that were also individually contributing as well. So I had more of an impact on what I was working on from a execution standpoint, if you will. And also appreciated that Raytheon has a really good work-life balance policy. So they had a 9/80 schedule where every other Friday you can take off, and you work 9 hours the other days, so that every other weekend you've got Friday off, which is really great, right? It makes for good weekends with individuals that you're working with or family. Sarah?
Okay, so as for me, I guess you could say similar to Neil, I started off in a different path, actually. I started in accounting, believe it or not. And I was actually at the time, I was getting ready to actually transfer to UCSB under the accounting and econ major. But I guess you could say that as I progressed further into my classes in accounting, I realized that it just was not fulfilling for me. I wasn't being challenged and it lacked creativity personally. And so I decided to go back to my career center at Santa Barbara City College. And I started thinking more and more about the type of classes that seemed to be my strongest courses, not just in high school, but then also at the community college that at the time I was attending. And so that's how I guess you could say that I discovered engineering. But in the end, I ended up going with mechanical engineering, mainly because of my statics class that I took at my community college. And from there, I transferred from Santa Barbara City College, I transferred to UCSB, and I continued taking my courses there. And during my, I guess you could say junior and senior year, I noticed that a lot of the projects that I was that I was a part of through my classwork. And a lot of those, I was always assigned or picked by my team members to be the project lead. So I guess it's part of the reason why I ended up also with this role where I'm a design verification engineer, because during that time in my undergrad, I did a lot of project management, but then I also ended up working at a research lab. And I realized that I enjoyed testing and, testing at the design level, I guess you could say, because even though I was studying at the time mechanical engineering, I also realized that you can't just come up with the design and then design it and build it without actually testing it and ensuring that it works. In order to perfect, or actually not perfect, but improve your design, you need to do a lot of iterations and a lot of prototypes and a lot of testing. And I guess you could say that that's part of the reason why I'm in this role. And I landed in this role because I developed skills that are necessary for this role. And with that, I'll pass it on to Jorge. No, Sam. Sorry, Sam.
Okay. Yeah, so similar to everyone else, I had a slightly different career path for a moment. I started off as a marine scientist. I did study marine biology as an undergrad. Was very fortunate enough to get to be involved in a couple different projects that studied how different environmental factors affect the health of coral reefs. And then came to UCSB to study, again, marine science for my master's. This time I worked with the California spiny lobster, which maybe some of you have seen along the coastlines. Again, looking at how the environment affects how they interact with their environmental systems, so the benthic marine ecosystem. And the things that I really loved about marine science early on are the things that I ultimately decided weren't for me in the long run. The type of research I was doing does require some sacrifice, like being away from home for long periods of time, long hours with not the best pay, and oftentimes having to move to wherever you're able to find a job as a researcher, which are things I wasn't quite willing to give up. And so the one part of research that I was not excited about when I started was the knowing how to work with my data appropriately and coding. And that's the part that I ended up falling most in love with. And it's given me a lot more freedom, a better paying job, the ability to work from anywhere, really, because you need a computer and internet access to do most of it. And really the ability to work really closely with large teams of people who are really passionate about, collaborative science, which I think is amazing. And so I think, despite the fact that I'm not doing exactly what I thought I was going to end up for my career in the long run, I'm much happier now. And I really encourage you all to be open to wherever life takes you, because sometimes it doesn't always go exactly the way you thought it was. And sometimes it leads you somewhere more exciting.
So for me, I resonate with Neil a lot. During high school, I thought I was going to do construction as well. More on kind of like the electrical side of construction. That's what I wanted to do. But it wasn't until my junior year of high school when I decided, you know what, I want to go to college, maybe try it, see what I can do. I entered college as an undeclared major. So as an undeclared, you just pretty much go in without a major. And then, I decided, well, I'm here now, I'm taking classes, what should I do? And then just kind of something with, engineering, kind of like, I thought it was interesting. And that's when I was like, oh, well, maybe I can try engineering. But now it's like, which engineering? Like, do I know which engineering I like? All of them I actually do like pretty different things. Some of them do electrical stuff, chemical. Some of them are there's aerospace, there's pretty much civil engineering, which is construction kind of side of engineering. There's mechanical engineering, there's computer engineering. There is computer science. There's pretty much anything you can think of. So now, like, how do I decide what I actually want to do? And I was like, well, but the best way to go about it is just take classes and figure out what I actually like. So I ended up actually going for mechanical engineering just because I thought it was really interesting. But I actually did not get into the major as it was really competitive. So I decided to go for physics. So physics is pretty much, the way I see it, it's pretty much explains how the world actually works. And from physics you can derive a lot of different engineering. And as a physics major, I did not actually get the hands-on I guess experience that a lot of engineers do get. So I had to put in a lot of extra work outside of my classes to do personal projects, get research labs, do internships in order to figure out, this is actually engineering, not only like the theory and like the science of how it actually works. So the way that I decided I actually wanted to be a design verification, test engineer at Karl Storz, it was actually my senior year of college. I still didn't know what industry I wanted to do, specifically what engineering I wanted to do. But I received an internship from Seymour Duncan. It is a local company in Santa Barbara, where I pretty much worked as a test engineer. I did a lot of testing for their electronics. And what made it really fun for me, it was not actually testing and getting everything to pass. What made it really fun for me was actually whenever I got failures, when something didn't work. And to me, it was like, okay, well, now I need to figure out why it actually doesn't work. And so that was a little more kind of electrical engineering based, but it was really fun being able to troubleshoot and figure out, specifically, in this electronic component, this part is the part that doesn't work. So I had to replace it and then test it again until I actually fixed the components. And I never actually knew the answer to everything, like sometimes I knew how to figure it out. Sometimes it would take me, maybe 20 minutes, 30 minutes, an hour. It could take me an entire day to figure out, what was actually wrong. And then that actually led me up to my current position. I guess to mention, I actually graduated from UCSB 9 months ago. So I'm a recent graduate from university, and I just started my role at Karl Storz Imaging recently. But that's kind of how it led me to become a test engineer. And what I like about my current position is being able to use all of those different fields into one single career path.
Okay, so everybody knows it's expensive to live in Santa Barbara County. So what are the ranges in your position, and what does someone just starting out make?
Yeah, great question, Gustavo. And Jorge, Sam, and Sarah mentioned there are a bunch of different kind of engineering trades, right? We talked about computer science, we talked about mechanical, electrical, industrial engineering. The list goes on, and each one of them at Raytheon has a different range, right? But starting salary within engineering, at least at Raytheon in the area, is somewhere between 65 and 90K. That's where you'd start. And so, the ranges, I did a little bit of research, and everybody else at home can too. There's a great resource called Glassdoor, where you can type the name of a role and a company and a location. It'll give you a range. So I got a couple for associate directors that I'll share with you. So an associate director at UCSB would have a range of 141 to 154. An associate director at Raytheon would have a range from 216 to 234, right? And depending on what company, what trade, what area you work on, the range will differ. But those are some numbers you can use at least for some starting points. Sarah?
Yeah, so as Neil mentioned, it does vary depending on the discipline, that you choose and that you go into as far as career goes. At least, I mean, I can kind of comment a little bit more on the design verification engineer. And thank you, Neil, also for sharing that website Glassdoor. I was actually going to mention that too, that if you type in the the for example, the type of engineering that you're looking into pursuing and at the starting or entry level, it'll give you like a little bell curve with like the lower and the average and the high ranges. But for my role, last time I checked, it was anywhere between, as Neil mentioned, 65 to about 90. Average here, at least in the Goleta, Santa Barbara area, from what I remember, it's like around 83, 85. So, I mean, I don't know I can't comment on the others, but, as I trust what Neil mentioned, it does really vary, and those ranges seem very appropriate, at least in my opinion. Sam?
Yeah, similar to everyone else, it varies. The great thing about working for the university or really any state employee is that those salaries are publicly available for you to look up online. And so anyone who works for the state, you can look them up. It's kind of weird, but I think it's really helpful and important. And I think, the topics of talking about salary is becoming a little bit more normalized, and that's really valuable from an employee perspective. You can also, every university job has a pay scale range that is publicly available. And so for my particular role as an academic coordinator, that ranges somewhere between 55 and 105, depending on the credentials you're coming in with. And every 2 years at the university, you get a slight cost of living adjustment automatically added. Plus you had this opportunity to apply for a promotion, which basically tell the university all of the things you've accomplished the past 2 years, and they'll bump you up to the next pay scale level. And so I think the real important thing is to negotiate, and it's a really scary process. And as you get closer to looking for jobs, talk to people you trust and who can help guide you through that process, because your starting salary is where you build up from. And a good boss or a good hiring manager will encourage you to negotiate and give you the time to think about what you want to ask for. And so that's a big topic of conversation to definitely have at a later time, but keep it in mind as you start thinking about your future jobs. I'll pass it over to Jorge.
So just a quick, I guess, keep it short. Mine is pretty much the same as Sarah. It could range between 60K up to like maybe 85, 87K, depending on how much experience you actually have. And how much you actually negotiate when you actually get your offer, like Sam said. So I guess to put it in another perspective, more kind of like the hourly, that it kind of, it's easier for everyone to understand. I believe 60K would turn out to be about 28, 29 an hour. I think so. And then 87K, 87,000 a year would turn out to be about 40, 42 an hour, like around that area. So it is a big range of, if you were to put it in hourly, kind of like to understand it for some of you that, might have experience working at other companies.
I'm going to jump in just to prompt Gustavo to ask his final question. And as he is asking his final question, I encourage teachers to submit. We have time for maybe 1 or 2 questions from teachers and students. So please put them in the chat box, and we may have time to answer them before we close.
All right, so final question for me. Do you need to be a top student to pursue a STEM career? And what education requirements are required for your role?
Hey, Gustavo, I'm glad you brought that up, right? You think of engineering, you might think, well, I must have straight A's and know I love eat, sleep, and breathe math, right? Well, that's certainly not the case with me and a lot of people that I went to school with. You need to know math. You need to know the sciences, right? But you don't have to be at the top of your class to graduate. I'll say it may help to get your foot in the door, but there's a lot of focus on aptitude and attitude, right? So the first has to do with what is your capacity to learn, right? Your curiosity. And the next also has to do with your interest in wanting to continue that, right? I've seen a lot of brilliant minds maybe come in places where I've worked, but they didn't further apply themselves and look at what was next. And you know, there's a digression that happens at that point, right? So I would say focus on having the attitude. You want to continue to learn, and I would encourage you, if you're not already, get involved with you know, science, technology, engineering, mathematics, and I'll say especially if you're not comfortable with it, right? Just like anything, just like any muscle, you need to practice it to get better at it, right? And some people don't practice it because they're not good at it to begin with. They're not innately great at it, but you know, that's where you learn, and that's how you become stronger, and that's how you benefit from being able to get out of your comfort zone and challenge yourself, right? So that's what I would encourage. Sarah?
Hi. So similar to what Neil said, I mean, honestly, no, you do not need to be top of your class. Yeah, similar to what Neil said, you do need to have some type of curiosity, you know, passion for learning things, you know, challenging yourself, grit. Grit is also important, and attitude, but above all, curiosity, you know, being curious about anything for that matter, whether it's a topic or, you know, an experience, because in school you're going to be you know, there's going to be a lot of opportunities, not just in class, but then outside, you know, in college there's student orgs. So challenging yourself and then taking, you know, advantage of all those opportunities that are out there, and then just allowing all those things to help shape your path. I think that's honestly the most important part of, at least for me, that's how it was in my undergrad, more so than, you know, stressing over getting all A's, because you will have other opportunities to develop other skills outside of the classroom that are equally as important, you know, beyond your academics. It's not just your GPA. Employers will not just look at your GPA. They do, but, you know, there's other things that inform them of how well of a round person you are. Sam?
I echo everything that Neil and Sarah just said. I would add that there are ways to gain experience and be involved in these communities, these STEM communities outside of school, because, you know, with the pressure of grades, it can be like nerve-wracking and throw you off your game sometimes. We see it all the time, you know, with the master's students that we teach. If there's no grades involved, then people are a lot more relaxed and willing to take risks and try new things that really help push them forward. And so Santa Barbara Women in STEM is an amazing community that, you know, covers a lot of different STEM topics, and anyone's welcome. No grades, of course, involved with that. And you get to network with people that you wouldn't normally interact with. I'm a co-organizer of this group called Our Ladies, which is a community of we focus on gender minorities and providing a safe space for them to learn coding skills in the R programming language. There are chapters all over the world. We have one here in Santa Barbara. So another great place to gain skills and meet people who have similar interests. When it comes to education requirements, most jobs I see only require a bachelor's. Having a master's can help. And there are, you know, a small set of jobs where PhDs are required. The one thing that people didn't tell me before I applied to grad school, and something that you should all be aware of, is that in the STEM fields, you should not have to be paying for your education. There are ways to get funding or to TA to cover the costs of tuition and earn a stipend while you're there. So it's definitely something that you should think about and explore if you are interested, and talk to people who might already be in grad school to gain greater insight there. I'll pass it over to Jorge to finish off.
So pretty much what everyone said, it was really good advice, and pretty much things that, you know, I guess are good traits. But something else that I think for me was really a big thing when I was actually studying in high school and in college as well, is learning how to learn. Because you can study, you know, 24 hours, but are you actually learning? That's kind of like the big question. Like, and the thing is, it's different for everyone. So you need to figure out how specifically for you, how does learning works? You know, how do you actually learn? Do you learn by doing more hands-on stuff, by doing more reading, by doing, you know, more practice problems? What is it specifically about you that, you know, makes you actually want to learn? So that's one of the things that I would encourage everyone to find out, like, how do you actually learn? And this can take, you know, years to figure out. I mean, I didn't really understand how I actually learned until I actually started my junior year of college. And that's when I actually learned how to actually properly study and how to properly learn the things that work for me. So that's one of the things that I would encourage everyone. And, you know, doesn't really matter, you know, what grades you currently have. It's more about, like, you know, what progress are you going to make in the next few years, you know, to get where you actually want to go. And, you know, make sure to seek for those mentors that will actually get you to those places.
I just want to say a big thank you to everyone for participating today. We are so glad that you shared your morning with us. Gustavo, you did a wonderful job. I hope you have a great rest of day at school. And thank you all for tuning in and joining us this morning. Keep dreaming big and discovering your career passions, and partners will be here to help you along the way. Erica from our team